In this video, we will combine our knowledge of dividing polynomials and factoring polynomials to solve and graph polynomials. So some reminders. When you have solved quadratic equations in the past by factoring, one side had to be set equal to 0. So it's going to be the exact same thing for polynomials. One side should be 0, then factor fully, and after that you can set each bracket equal to 0 and solve. In terms of graphing, we know we need factored form, and then we can look at the order of each of the factors, or 0. If it's to the power of 1, it's a pass. If it's to the power of 2, it's a bounce. If it's to the power of 3, it's a point of inflection. We also tend to find our y-intercept and think about the end behaviors using the degree and the sign of the leading coefficient. So let's start with our first example. F at x equals 3x cubed plus 10x squared plus 4x minus 8. Let's solve f at x equals 0, and then let's also graph f at x. All right, let's say we are doing the solving first. So I'll set my equation equal to 0, and now it's time to factor. All right, so time to factor. I'll keep in mind that the factors of 3 are 1 and 3, and the factors of 8 are 1, 2, 4, 8. So I can use any number that is these factors divided by these. So I'll start with 1 and -1 and see if that works out. And it doesn't. So then I might try 2 and -2, 4 and -4, 8 and -8, and then all of these divided by 3. Now as you try them, the option that works is -2. When I do f at -2, I get 0. That means the factor is x plus 2. So let's go ahead and do our division, and you can use long division or synthetic division. I'm going to use synthetic. So I'll put my coefficients on top, and my factor for the bracket is -2, because if the bracket is x plus 2, the factor is -2, and now let's divide. Drop the 3 down. 3 times -2 is -6. Add these up and you get 4. 4 times -2 is -8. Add these up, you get -4. -4 times -2 is +8. Add these up, you get 0. That's your clue that you've done this correctly. You found the correct factor because the remainder is 0. So that means our equation is now x plus 2 from our factor. And then because I did cubic divided by linear, I will have a quadratic for my quotient. And now I can factor this using crisscross or whatever method I would like. So I'm going to do 3x and x, and then 2 and 2, with this one being negative. That way we have 6x and -2x. So we have 0 equals x plus 2, 3x minus 2, and x plus 2 again. So our solutions are x equals -2 and x equals +2/3. And I'm not going to write the -2 from the third bracket because we already have it. And there we are. The factoring is a little fancier than in quadratic, but very similar style for the end goal. All right, now let's graph. So f at x, I'm just going to clean it up because I see the same bracket twice. I am going to write it as x plus 2 squared. And then here we are. Now I see my zeros are -2, which is going to be a bounce, and 2/3, 0, which is going to be a pass. Notice the zeros and the solutions match. I also see that I have a positive leading coefficient with an odd degree, which means we're going to have an overall upwards trend from quadrant 3 to quadrant 1. So now let's roughly sketch this. Oh, and actually we also know our y-intercept. Just like in quadratic standard form where the constant is your y-intercept, same thing with other polynomial standard forms, because if I set any of these x's equal to 0, they all disappear and we're just left with that -8. So there's our y-intercept. I mean, you could also set the x's in your factored form equal to 0 and it'll get you to the same place, but if I have standard form, that is a lot quicker for me. 1, 2, 1, 2, and 2/3 is at 0.6 repeated, so I'll plot that point and label it. And then we're gonna bounce at -2, pass at 2/3, and I'll also plot my y-intercept and I'll just say it's roughly here. And we have to start in quadrant 3. So I start here, I'll bounce off, I'll go through my y-intercept, and then I'll pass through. And there's my graphing. Same graphing, it's just now we have to turn our standard form into factored form to get to the same place. All right, let's go to our next example, and we are solving the following equation. One side is already equal to 0, so we don't have to bring anything over. We just have to go straight to our factoring. I notice there's a GCF of x, so I will factor that out. And now we just have to factor this cubic part. So looking at this cubic function, because the coefficient is 1, the potential factors I'm going to try should be multiples of -16. So plus or minus 1, 2, 4, 8, 16. I'm going to start off with 1. When I plug in just 1, it doesn't get me to 0, so that's not good. If I try -1 though, I do get 0. So try that out for yourself to make sure it works. You don't have to believe me, but x plus 1 is a factor because plugging in -1 gave us 0. And when we do our synthetic division or long division, we will verify that by getting that 0 remainder. So I'm going to list out my coefficients. None of the terms are missing. Drop down the 1. 1 times -1 is -1. Add these up and I'm at 0. 0 times -1 is 0. Add these up and I'm at -16. -1 times -16 is +16. Add those up. There's my 0 remainder. So what are we left with? X plus 1. Oh, the common factor out in front. So the x first, the x plus 1, and then because I did a cubic, so power 3 divided by power 1, I will be left with quadratic. So x squared, then plus 0x, which I'm not going to write, and then minus 16 equals 0. And now when I look at this, the quadratic is just a difference of squares, so I'll factor that nicely. X plus 4, x minus 4, and now my solutions. X equals 0, x plus 1 equals 0, which means x equals -1. X plus 4 equals 0, which means x equals -4. And x minus 4 equals 0, which means x equals 4. And those are my solutions to this equation. And now let's do a final graphing one. So we're going to graph g of x equals x to the 4 minus 3x cubed minus 6x squared plus 28x minus 24. Well, some things I already know. I already know my y-intercept is 0, -24 from the standard form. I see I have a positive leading coefficient with an even degree, which means the end behaviors will go in the same direction, and because the leading coefficient is positive, they're both going to go positive forever. So that's quadrant 2 start to quadrant 1 finish. And now let's factor. There is no common factor here, so we have to jump straight to trying to find a factor. Again, my leading coefficient is 1 here, so I just need to look at multiples of -24. So that's going to be plus or minus 1, 2, 3, 4, 6, 8, 12, 24. There's a bunch for this one, but of course I will start with 1 and -1, which if we try punching it in, do not work. So now I'll try 2. And if we do 2 to the 4 minus 3 times 2 to the 3 minus 6 times 2 to the 2 plus 28 times 2 minus 24, we do in fact get 0. So g at 2 equals 0, which means our factor in bracket form is x minus 2. And now let's do synthetic division. 2, and now the coefficients, 1, -3, -6, 28, -24. Bring down the 1 and do the multiplication. 2 times 1 is 2. Add these up, we get -1. 2 times -1 is -2. Add these up, we get -8. -8 times 2 is -16. Add these up, and we get 12. 12 times 2 is 24. Add these up, and we get 0. Very good. So what is g of x now? Well, it's the x minus 2, and then we divided something to the power of 4 by something to the power of 1, which means our quotient will be cubed. So x cubed minus x squared minus 8x plus 12. Now what we're left with here is cubic. So I'm going to have to repeat the process here. Let's do another set of trying to find a factor and then doing another synthetic division. Now, if 1 and -1 didn't work the first time, they're not going to work here either. So I'm going to try 2 in case it's another factor, and then I'll try -2 and so on. And if we plug in 2 here, we get x minus 2 is another factor, because we get 0. So I'm going to do my synthetic division, this time on the cubic. So let's repeat. Bring the 1 down. 2 times 1 is 2. Add them up, we get 1. 2 times 1 is 2. Add them up, we get -6. -6 times 2 is -12. Add them up, we get 0. Very good. So that means we have g of x equals x minus 2 from the first time, x minus 2 from the second time, and now we're left with a quadratic, which we can do a quick crisscross or whatever factoring you want on, and let's see what we have. If I need to get to -6 and add up to 1 when I do my crisscross, I'm going to have x minus 2 again, and then x plus 3. So when I clean this up the final time, because now it is fully factored, I have x minus 2 3 times and x plus 3 once, which means 2, 0 is a point of inflection. -3, 0 is just a pass, and we have our y-intercept. So let's get a sketch going. Here's 2 for the point of inflection. Here's -3 for the pass, and we know we're starting in quadrant 2 and ending in quadrant 1, and we know our y-intercept is at -24. So now let's connect the dots. And here it is. And you'll notice that I didn't treat the y-intercept as the minimum point, just because if I were trying to approximate where that minimum would be, which it's not going to be accurate, but I would average these values, and it's going to be around the -0.5 mark. So I didn't make that a minimum. And that's it. 2 times synthetic division to get this factored, and then back to basics with our graphing.